Hey guys, thanks for popping in and checking out my tutorial on Fusion 360. Some light computer aided drawing. Gonna pop it up into a 3D object, gonna slice it into pieces, and then we're gonna 3D print it. So this is how that goes. All the software I'm using in here is free. So I'm gonna start with Fusion 360, which is an Autodesk product. Now, as long as you are, actually I don't need to launch it, I have it open on here. Boop. As long as you are a hobbyist or a student or an educator, it's free. And even if you're using this for your business, if you're a startup or a small business, as long as you take in less than $100,000 a year, then it's still free. And even after that, it's a sliding scale. So once again, very cheap. So Fusion 360 is awesome. It's a CAD CAM, so it has a little bit of everything in here. We can model something. We can build a model from scratch, what we're going to do. You can deal with parts of it. You can build a sheet metal model. So you can build a model and then it'll break it down into a foldable object that can, be bent into this. You can render stuff. You can animate moving parts and interactions. You can run finite element analysis simulations, which are super great for, building parts that are actually going to be used instead of just a mock-up part like this, because that's what this is. And then CAM for machining, and we'll get into that a little bit, but not really. And then drawing is, it's what it is, it's drawing. So we're going to come back over here to our space. And what I have is I did a break swap and then built spacers for the front end to get everything dialed in so I could order the right part the first time. And then I come to the rear end and I realize I still need a little bit of a spacer to clear the brakes. And I can easily get a 1/4-inch spacer at Summit tomorrow morning if this works. So I'm going to design a 1/4-inch spacer and print one up and give it a test run and see what's what. So we're just going to start. We're going to come over here to Sketch. We're going to go to Create Sketch, which is going to give us some planes. So if we take this part right here, left click and rotate it, you can see that we have different planes that we can draw. We can draw on the floor. We can draw on these walls because this is a 3D space. It's a 3D space. I'm going to come back over to the top. I'm going to select the floor. So that's what I'm going to use. So I'm going to center click on my scroll wheel just to kind of center this guy up. And then we're going to get started. So this is just a series of circles, right? It's a spacer. So go sketch, going to come to a circle, going to do a center diameter circle. So that's just going to do us, we're going to measure by the diameter of the circle. So I'm going to open this up a little bit, and the center bore of the brake or the outer of the hub is, I think it mic'd out to just under 72 mil. So I'm going to go ahead and do this at 74 mil to give myself plenty of room. Boom, boom. Whoa, look at that. That was garbage. Undo that. Let's try that again. Repeat. Boom. Bring that out. 74 millimeter. Look at that. Not dyslexic after all. So what that gives me is a 74 center diameter circle. So awesome. Now I've got my center point. Going to click in the middle again. Going to repeat my center diameter circle. Man, say that 1,000 times fast. All right. So the lug pattern on the C6 Corvette is 120.6 millimeters, which comes out to 4.75 inches. I don't know. I don't deal with standard inches as much as I can avoid it. I immediately convert to millimeters because I like the numbers better. So now we've got our center bore and our lug circle, and then we're going to do one more circle. Well, I'm going to do 2 more circles, but I'm going to come out here and we're going to do 165. Let's do 165 for the outer flange. That makes good round numbers that I like. And that'll give us the outside of the flange. So what we have is this is the face of our spacer, this is the inner hole, and this is the outside of it. Now what we need is some holes for lug studs to pass through. So I'm going to come here, I'm going to click again, repeat my center diameter circle. See, I'll get it right eventually. Let's see if I can get the snap on there. Boop. And I believe the stud is a 12 mil stud. So we're going to go ahead and open this up to 14 mil because extra space for 3D printing slop and me getting my math wrong and just ease of use. So enter. All right, so now I have a lug hole. So I'm going to take this locating line, left click on it, or yeah, left click on it to highlight it. and then I'm going to right click on it and delete that bad boy. So now I have a pattern from which I'm going to extrude. So I'm going to right click, click press pull, and 1/4 of an inch is 6.35 mil, if I remember correctly. Boop. Now I have a 3D object. Look at that. That's cool. And so extruding is like the super important. This is very important part of taking a 2D thing and making it 3D. It's the ability to pull it or push it in Z dimension to give it thickness or weight. And you can use it to make lots of parts. And this is really the most simple thing I'm going to make. So I used it for my first video. I'll show my models and my modeling process in the future, but they're going to be, vastly more complex. All right, so I got one hole. That's not enough holes. So I'm going to go to create, left click. I'm going to drop down here to pattern, and I'm going to make a circular pattern because, lug nuts, right? So a circular pattern. I'm going to select the face, and then I'm going to select the bore of the hole because these are the parts I want to replicate. And then I need an axis. So I'm going to select the upright axis because we need to pivot around something, right? All right, and I need 5 holes. Boom, spacer, done. That's it. Without talking through this, I could bang it out in seconds. These simple parts are easy. And if I wanted to build a flange in here, I could just draw another circle, select it, draw a circle of the thickness of the flange I wanted, select it and extrude it up some more. Or if I wanted to machine this, I'd want to break these sharp edges, right? So I just select this edge, right click on it, and chamfer's automatically going to pop up. So if you use SolidWorks or anything like that, and it's just a super clunky, tons of menus on menus on menus, stuff you have to deal with over and over again, Fusion is so much better than that. It is just intuitive as hell, and I love it. So I can chamfer it. Let's do a 1 mil chamfer. Boom, look at that. Look at that nice shiny chamfer. That's great right there. That's all 3D and stuff. Anywho, all right, I actually don't want the chamfer because this is a 3D print, and I'm trying to keep shit simple. So center clicking on the scroll wheel. Now, if I wanted to drop this down into CAM, computer-aided machining, man, I could. There you go, adaptive clearing over here for digging stuff out, and multipass. The adaptive tool paths on here are so good. This has just been a dream software to have access to. I've cut stuff out from a simple 3D router, cutting molds for composites, to my own little at-home mill, to etchings, to engravings, to hogging out aluminum on big ol', multi-axis, multi-tool Haas machines. This is awesome. It speaks multiple languages. You can simulate your machining process. It's really, this is for dummies. I'm a dummy and I can make this work. Now, all this is cool, like simulation. We're not going to go into the simulation workspace because it's going to take some load time, but we could apply forces to our part and see where it would fail or stress, or what the stress points would be, or how we could design it better to keep those from failing. And if that's something you're interested in, if any of this is something you're interested in, Fusion has awesome YouTube tutorials that'll teach you this stuff. I'm not going to say in no time flat. It's complex and it takes some input from your part to get it done. But man, I've not had support on a program like this ever in anything. Anyway, I'm going to pop back to the model, and because right now we're 3D printing stuff, we're not machining. We'll be machining stuff later. So I'm going to hit make right here, 3D print, boom. And I'm going to select, I'm going to zoom out a little bit. I'll select this whole bad boy right here. Click. All right, so it's dropped it into mesh. And what a mesh is a computer's version of locating every part of your part with triangles. So this is a fine mesh, and you can go finer in custom settings, but this is, great. It's going to come out round. Now, if you were, didn't matter, wanted to bang it out really fast, you could put it on low, and it'll be a little more polygonal because, polygons. But, that'd probably be fine, but my tolerances would be poopy in here and in here. And yeah, my thicknesses would probably be medium to uneven. So I'm going to leave it on high. That's great. All right, so I like that. That looks good. Now I'm gonna hit OK. Boom. It's gonna pop up body 1. We're gonna go body 3 because I've had a couple different versions of this part. So body 3, it's an STL file, which is a CAD file. Say that. Plop. And we're done with Fusion for right now. Next, I'm going to open up Cura, which is a 3D slicing software. And I'm zoomed way in on my build plate. And it's got almost the same mouse controls. Center wheel zooms in and out, right click to rotate. It's dead simple, dead simple. So I'm going to come over here. I'm going to open a file. And I'm going to open body 3, which is the thing we just made. I'm going to open it. Boop. Oh, all right. What are we in? We're layer view. That's not good. Solid view. Okay, so dropped it in or vertically. And we could print it like this, but it needs some supports and it would take a long time and it'd probably get some sags in here unless I tune everything just right. And I don't like having to mess with all that nerd stuff. I'm not making, you know, Star Wars figurines. It's a spacer. I mean, who cares? So let's go ahead and select the object. Cool, we've selected it. We're going to rotate it. Let me spin me around here a little bit. And grab this guy. Whoa, buddy, whoa. And drag it around to 90 and let it go. All right, so it's still kind of hovering in the air, which we could print it like this. It's gonna have to build supports and take a lot more time, and the surface finish on the bottom will suffer, and that's no fun. So I'm just gonna, since I haven't selected, I'm gonna go to move. I'm just gonna zero out the Z-axis and drop it on the deck. Clank. All right. So now we've got this on the deck. That's a good printing location. It's right in the middle. There's plenty of space. So we're going to come over here to setup, and I'm going to move me over here. Doop. All right. So over here in the settings, you can see that I'm running a Creality CR10S, which is just a $500 cheap Chinese 3D printer. It is great. I had a Delta printer back in the day. It was garbage. I've run some industrial printers, which, I mean, I guess it was years and years ago, so they kind of were okay, but they're really expensive and really difficult and had a lot of failures, and you couldn't service them. And this was $500, and I've already messed it up a couple times and fixed it by watching YouTube videos. So, you know, your mileage may vary. It depends on if you're a tinker or not, but it's pretty easy. Material I'm printing in is PLA. I'm using eSun PLA Plus. Been great so far. Profile, let's see what we're doing here. Let's see what we've got set up here for presets. So layer height of 1.5, that's fine. We're gonna bump that up to 2.2 millimeters per layer, just to print a little bit faster, because this is a spacer, it doesn't need to be fancy. Inner wall thicknesses are all fine. Wall overlaps, infill, 10% infill density. So infill, excuse me, hiccups, is the amount of material that it prints inside of the object as reinforcement. So 10% is pretty sparse, but you know, 100%, I mean, that's a solid wad of plastic, and that's not really necessary either. This is just for, you know, prototyping, mock-up. So I'm just gonna double that up. Let's do 20% infill. Triangles are what you expect. They're just, you know, triangles, and that works pretty good. But I've been playing with gyroid, which is their own name for 3D honeycomb. So it's basically a honeycomb that moves in a triaxial way. So it should be supportive in all directions. I'm not totally sold on it, but I'm going to mess with it for a little bit anyway. Extra infill wall count, Printing temperature 200. That's fine. My printing temperature generally ranges between 195 and 215, depending on what I'm doing. Something flat like this, 200 is great. Initial layer, let's bump that up to 215 because I'm printing directly on the mirror. I don't have any tape or glue or anything like that, and it's nice to have a good stick on the first one. Build plate temperature 60°C, just fine. Retraction, super important. Retraction is the amount the filament pulls back when it moves. That way you don't get strings connecting all of your little parts, because that sucks. I fought that for a long time. 5mm retraction is fine. 40 millimeters a second is fine. Print speed 60. 60 is pretty quick. Sometimes I'll bump it up to 80 if I'm doing something really rough, 40 if I care. Let's look at fan speed 100%. Build print adhesion type is a skirt. It's just going to prime the nozzle by going around it a couple times in a circle. So that's easy. All right, so let's slice it. Ka-cha. See how long this is going to take. Three hours and 49 minutes. So I could come up here and trim some stuff and probably get it out in about 2 hours, maybe 2.5 hours. But I'm in no hurry. I'm going to let it run overnight and check it in the morning. Hey, I'm going to go ahead and save, which I'm not going to because actually I already have it saved and it's already printing over my shoulder. I'll put some of that print footage in here towards the end. So just overlay it here somewhere, or I'll tack it onto the end. I haven't quite figured it out. But hey, I hope you found this useful or at least interesting. Everything I talked about and everything from the software I use to the 3D printer and the filament I'm using is all going to be in the description. So if you're interested in any of that stuff, cool. If you found this video on happenstance and don't know what the hell I'm doing or why I'm making a wheel spacer, this is a sub video for a mother video that I put up, and the mother video will be the top link. So you can go see why this is all happening, and maybe it'll make a little bit more sense. If you like it, give it a like or whatever those buttons. There's all sorts of buttons, and you're on YouTube, so you know how it works. But please give me some feedback. Let me know what you want to see. Thanks for watching. Take it easy.
Perfect.